Hello everyone, welcome to Homework Help. If you find the videos useful, please subscribe to the channel. So in this video, we'll solve this problem using the concept of equation of a line. So as per the problem, a line has y equals minus 5 over 6x plus 9 as its equation. In part A, we have to give a direction vector for a line that is parallel to this line. So let's start with part A. Now the given equation is in slope-intercept form. The slope of this given line is negative 5 over 6. We have to find the direction vector for a line that is parallel to the given line. We know that parallel lines have same slope. The formula for slope is rise over run, and we know that rise is along the y-axis and run is along the x-axis. So a direction vector for a line that is parallel to this given line can be negative 6, 5, because we write the x component of the vector first. We use the run value for the x component and the rise value for the y component. We can make either of these components negative because the slope is negative. So for this problem, I made the x component negative. So this should be the final answer for part A. Now we can analyze part B. Give a direction vector for a line that is perpendicular to this line. Now the slope of the given line is negative 5 over 6. Now we know that perpendicular lines have slopes that are negative reciprocal of each other. So the slope of a perpendicular line will be 6 over 5. So we flip the slope value and change its sign. So it became positive. And we know the formula for slope is rise over run. And the rise is along the y-axis and the run is along the x-axis. So the direction vector for a line that is perpendicular to the given line is 5, 6. So there is a very important concept we need to understand and memorize. So this should be the final answer for part B. Now we can analyze part C. Give coordinates of a point on the given line. So in the slope-intercept form, the number represents the y-intercept of the line. And the y-intercept for this line is 9. So the y-intercept can be written as an ordered pair. So this is a point on the given line. Now we can answer part D. In both vector and parametric form, give the equations of the line parallel to the given line and passing through point A 7, 9. The first step is to write the equation in vector form. So let's start by writing the general equation in vector form. In this equation, vector r represents the position vector of an unknown point on the line. Vector r0 represents position vector of a known point on the line. And t is a parameter and it can be any real number. And m is the direction vector. So we know that point 7, 9 lies on this line. So we can use that for the position vector r0. And in part A, we found that a direction vector for a line parallel to the given line is -6, 5. So this is the vector equation of a line parallel to the given line. Now we can write the parametric equations. So for that, let's assume the position vector r represents the unknown point xy on the line. Now we can break up this equation into the parametric equations. So let's start with the x equation. So we'll use the x components of the two vectors on the right side, and for the direction vector we'll multiply the components by t. So the x equation will be 7 minus 6t. So we use these components. For the y equation we'll use the y component and we'll multiply 5 by t. So this is the y equation. So these are the parametric equations for a line that is parallel to the given line. Now we can answer part E. In both vector and parametric form, give the equations of the line perpendicular to the given line and passing through point B. So we'll start by writing the general equation of a line in vector form. So this line passes through point B, so we can use this point for the position vector r0. And in part B, we found the direction vector for a line that is perpendicular to the given line, which is 5, 6. So we can use that in this vector equation. So this is the vector equation of a line that's perpendicular to the given line. Now we can write the parametric equations. So we'll use the point xy for the position vector of unknown point on this line. Now we can write the parametric equations using the x and y components. So the x equation will be, and the y equation will be. So these are the parametric equations for part E. So these are the steps you have to keep in mind to solve a problem like this one. So I hope you'll find this video useful. Please share it, like it, and subscribe to Homework Help. Thank you very much and have a nice day. Bye.